Hi, this is Tarik Rashid. Support vector machine, part 3. Part 1 was the theoretical part. Part 2 was the linear problem solving implementation of support vector machine. And part 3 is about how to solve a nonlinear problem. Okay, that's the part 3. Now, if we have this example, positive class, 3 by 3 point, 3 by minus 3, minus 3, 3, minus 3, minus 3, 3, and likewise negative class, 1, minus 1, minus 1, minus 1, minus 1, 1, 1, 1. So x-axis, y-axis, x-axis, y-axis. So this, we need to plot them into x and y, see whether they can be separated linearly. If not, then we have to have a trick to solve it. So this is the points. Okay, um, this is the point. That's 3 minus 3. This is 3, 3. This is minus 3, 3. This is uh, minus 3, minus 3. So minus 3, minus 3. This is minus 3, 3. This is 3, 3. This is uh, 3 minus 3. And this one is 1, 1. This is uh, minus 1, 1. And this is minus 1, minus 1. And this is 1 minus 1. So these are the points that we saw them. And it's very difficult to have a linear line to separate all the points. So these are the red points, which are negative, and these are the positives. There is no linear line can separate all these points. So it's very difficult. Thus, we need to uh, convert data points from 2 dimension into higher dimension. So we can do it by having a kernel trick. A kernel trick can solve this problem by mapping the 2 dimension features into 3 dimension features. We call phi or phi, using a common nonlinear mapping. For example, polynomial kernel of degree 2 or Gaussian or sigmoid or any other functions. So here we use z x1 square plus x2 square, and that's how we convert each data point into higher space. So that is the data points, 3 by 3. It'll be 3 square plus 3 square, 9 by 9. P2, 3 minus 3, 3 square minus 3 square. It'll be 9, 9. That's how we convert it. And that's for positive class. These are for negative class. Okay. 1 square minus 1 square, 1, 1. It'll be minus 1 square minus 1 square, 1, 1. That's how we convert all the points into Z1 and Z2. Now, now we converted the point. We can see this point is 9, 9, the first point. And there's also a point, this is 1, 1. And you see uh, here I can, if these are the two support vectors, I can simply make a linear line to separate them, But before that, we couldn't make it. If you look at this one, we couldn't make it. There is no separate line that can separate all points. So I need so many separate lines to make them, and that's difficult to work with so many data. So now I take the support points 9, 0, this point, 9, 9, sorry, 9, 9, and 1, 1, these points. So these are the points that I look at them, and I can now linearly separate these two by a hyperplane. So I'll use negative support class 1, 1 and positive support 9, 9, And next, I try to create augmented vectors. As we said earlier in our class, we can create augmented vectors by adding element 1 bias, positive 1, which represents bias to support vector machine. So that's 1 and that's 1 were added for both support vectors. Now we're trying to use equation W, which is the vector W, which is perpendicular to the hyperplane, will be formed by sigma alpha support vector sub I. So alpha 1 support vector 1 multiplied by support vector 1 plus alpha 2 support vector 2 multiplied by support vector 1. If you have support vector 3, you will do plus alpha 3 support vector 3 multiplied by support vector 1, and so on and so forth. So this equation was formed. For the second class, for the positive class, again, alpha 1 support vector 1 multiplied by support vector 2 plus alpha 2 support vector 2 multiplied by support vector 2. If you have another support vector, let's say you took 4 points support vector, so you would say plus alpha 3 support vector 3 multiplied by support vector 2 plus, if you have another one support vector, you can say plus alpha 4 support vector 4 multiplied by support vector 2. And that's how it works. So these are because we have two support vectors, now we have only S1 and S2. Now alpha 1, we found it's -1. Alpha 2, we found it 0.2. So we plug them into our equation, W, and now we have plugged them -1 multiplied by 1, -1, -1 multiplied by 1, -1, -1 multiplied by 1, -1, 0.2 multiplied by 9, 1.8, 0.2 multiplied by 9, 1.8, 0.2 multiplied by 1, 0.2, -1 plus 1.8, 0.8, -1 plus 1.8, 0.8, -1 plus 0.2, minus 0.8. So these are the z that we found, 0.8, 0.8, minus 0.8. This is 0.8, 0.8, minus 0.8. So we plug them into W equation, which is represented by z. We can't do it by x because x was 2-dimensional. Now we went to the higher dimension. So multiply or divide by 0.8. Divide by 0.8, it will be z1 plus z2 minus 1 equals 0. Okay, so let's say if we have a middle point between support vector and the point earlier, two points. So in this case, we have 1 plus 9. So the 1 for first support and 9 is for second point. So 1 plus 9 for the x-axis over 2, 1 plus 9 for the second point y-axis. It will be 2. So 10 divided by 2, 5. 10 divided by 2, 5. So these are, we plug them into the weight vector 1 and 1, and we will get b is -2. B is -2. So that's the kind of radius of the hyperplane. So that's how we create hyperplane. x1 plus x2 minus 10. That's how we can do it in hyperplane. So the radius will be 3.16, square root of 10, 3.16. So this is the radius of the hyperplane that separates data into two classes, positive and negative. Now, that is the radius, which has square root of 10, 3.14, and these are negative class, outside is positive class, and you can see how the data was separated. Now, if we try to test any data. For example, we have 3 by 3, 0.3 by 3. Plug it here, 3 square, 9, plus 3 square, 9. So 9 plus 9 is 18. Greater than 10, yes. So this is a positive point. Now, if we have a negative point, for example, if we say minus 1, minus 1. So plug minus 1, it will be minus 1 square 1, minus 1 square 1. So 1 plus 1, 2, 2 less than 10. That's a negative point. So this is the testing point or the testing equation for to classify your data into plus and minus. I hope it was useful and enjoyable, and looking forward to uh, provide more tutorial in the